Hello Year 12 and welcome to the final episode of Mathematical Mo Brain Movies in this short series of tips and tricks to help you succeed in the trigonometric topic. Let's get straight into this one. This tip's a pretty straightforward one, but we're actually going to illustrate it using some fairly tricky questions because I need you to practice them. So the tip itself says draw or redraw diagrams or parts of diagrams bigger and clearer. So it's not rocket science, is it? But we're going to see how important this is as we do some of these tricky questions. This question here, you can see it's a little bit complex straight out. You're asked to find the length of AC, and I'm telling you straight up that this is going to be a multi-step question where you're going to need to use that other tip on thinking backwards to work forwards. Before we even get into that, let's think about the very first tip that you were given, and that is to put on as many of the angles as you can do whenever you see a question. So I'm going to look at this diagram here and see if there's any angles I can get. I'm going to start by drawing it a bit bigger because as soon as it gets some angles in there, it's going to be messy and things are going to be hard to see. So I know that this is 55, so that's where that tip comes in. I know this is 60. I know this is 15. Can I work out any other angles here? I know this is 11, I'll just whack that on. Well, hopefully you can see how you can work out another angle. I can work out this angle here. And I can do that because I know that these three angles form a triangle and they have to add up to 180. So I'm going to say to myself, well, what do these two add up to? 60 and 55. 60 plus 55 gives me 115. So this one must be 180 minus 115. So I'll whack that into my calculator. Gives me 65 degrees. So this is 65 degrees here. So I say to myself, can I work out any other angles? Again, remember, I haven't even really worried too much about the question at this point. I'm just worried about trying to get as much information out there as I can. And yeah, I can work out this angle here. How can I do that? Well, these two angles form a straight line and I know they must add up to 180. So if I know that this one's 65, then this one must be 180 minus 65, so this is going to be 115 here. I say to myself, is there anything else I can work out? And yeah, there is. I can also work out this angle, because I now know what these two are, and these three in my triangle must add up to 180. So I say, well, what's 115 and 15? That's 130. So this one has to be 180 minus 130. It must be 50 degrees. So you can see that before I've even gotten too far into my question, I've managed to get a whole lot of information on, which is really good. Let's have a look at the question. It's asking me to find the length of AC. It's actually asking me to find this length here, all the way along here. Now I can see that in order to find the length of AC, I'm going to need to know this length here. Let's call that length X. So I'm going to need that. So I can see that my final step here, because I'm going to do a multi-step thing here again, that my final step here to work out what AC is just going to be X plus 11. Just going to be adding those two things together. Of course, I need to work out X. So, to get to that one, I need to think, well, how can I work out X? That's what I've got to find. So, if I'm trying to work out X, I can see here I've got some angles. I've got plenty of angles, no worries there. But in order to work out X, the minimum number of sides I'm going to need here is 2 sides, because then I could use the sine rule. The cosine rule requires 3 sides. A bit more effort. I'm going to try and use the sine rule because it only requires 2 sides. So I'd look at this question and see and think to myself, am I going to be able to work out either of these sides easily? This side probably not, because I need a bit more information to work out that side. But I look at this side and I think I can probably work that out. I'm going to call that Y. I'd redraw this triangle so that I could see it a little bit clearer, the triangle that I'm working with, and maybe it'll spring out to me or jump out at me a bit more then how to go about calculating this. So this is this triangle here, just the one on the right hand side. I know that this is 55. I know that this was 11. I'm trying to work this out. I know that this is 65 and I know that this is 60. So, can I work out what Y is here? Well, yes I can. I've got 2 sides here. I've got 3 angles. I've got plenty of angles. But I've got 2 sides and I've got two angles. I need 2 angles in order to use the sine rule. So I'm going to say to myself, in order to work out X, I'm going to need to work out Y. So there's a step before this, and that is working out y. So I say to myself, how am I going to work out y? Well, I'm going to use the sine rule. So I'm going to use the sine rule here to work out y. That's going to get me this. Once I've got that, then I'm going to know again some pairs here. That'll be a pair. That'll be a pair. So I'm going to use the sine rule again to work out x. Then I'm going to use that last little bit there. So let's work our way through it. Sine rule to calculate y. Well, here's my little question here. I'm trying to work out a side, so I'm going to set up my sine rule like this. A over sine A equals B over sine B with my sides on the top. Y is what I'm trying to work out. So y over sine, what's it paired with? What's the opposite one? 55. My other side is 11. That's going to have to be the one on top. And what's it paired with? It's paired with sine 60. So this one here I didn't actually really need. So you've got to be able to discern which information is important here. So y here is going to be, remember you bring this up and multiply, 11 times sine 55 over sine 60. So on my calculator, it's going to be 11 times sine 55 over sine 60. So I've worked out that my y there is 10.40 degrees. So I've now got my y is 10.40 degrees. Again, you can see everything's getting cramped. So before I have a look at this triangle, I'd redraw it. Now I'm actually a little bit limited with my space here. I'm actually just going to get a new bit of paper. So here's this triangle here, redrawn. So remember, I'm trying to work out what x is so that I can add it on to 11. I know that this side now is, not 10.40 degrees, it's a length, sorry, 10.40. Get rid of that degrees over there too. It's a length, so it's 10.40. I know that, well, I'm just going to look at it and see which angles do I need that are going to pair with this. Well, I'm going to need this angle here to pair with x, so I know that one's 15. I'm going to need this angle here to pair with y, or pair with 10.40. That's 50. Back to my sine rule. Again, I'm trying to work out a side. So I'm going to set it up like this. I've got a bit more space here, so I'll spread things out. But again, you can see the importance of redrawing these diagrams each time to make it clear what you're trying to work out. So let's have a go. I put my unknown on the top, x. It pairs with the angle 15. I put my other side on the top here. It pairs with the angle 50. How do I work out my x on its own? I'm going to bring this up and times. So I'm going to end up with sine 15 times 10.40 divided by sine 50 will give me x. So let's do that. So I've got sine 15 times 10.40, or I could have just pressed answer there, divided by sine 50 gives me 3.513, whatever it is. Okay? It's always good to leave, and I should have left a few more numbers up, a few more digits after that, because you don't want to round right until the end, or you can get a rounding error going through your work, and they'll dock you a mark for that in the HSC. So that's poor practice by me, so just ignore that. Make sure you leave lots of numbers in there on your calculator and you type them all in, or you use that answer button to recall your answer. Okay, so I worked out y. Tick. I've now worked out x. Last step is that I need to work out AC by doing x plus 11, because that's going to give me that full length. So AC then is x plus 11. My x, again, to avoid those rounding errors, I put in as much as I had. I should have left it all for that last step, as I mentioned. Add on 11 is going to give me 14 point. Now here's where I'll round, just to 2 decimal places. So you can see it's a tricky question. It's multiple steps. You can see the importance of doing the diagrams, and you can also see the importance of that first tip to put in as much information straight away as you can. All right, last question before you finish up for the night. It says the angle of depression to a boat from a 100-metre high cliff is 78 degrees. So you can see they've drawn it there. The boat sails toward the cliff and has a new angle of depression of 84 degrees. So that hasn't been marked, it doesn't look like. And it says how far has the boat moved. So again, well, you can't even read it, sorry, because I've got it on an angle. So again, I would draw this bigger so everything was nice and clear. So here's my cliff, here's my boat somewhere out here, and I've got my boat here somewhere. And my first angle of depression, remember that it has to be from that top bit there, is 78 degrees. And then it says it sails in a bit, and the new angle of depression to that boat there is now 84, so that's my bigger one here. They're asking me how, they've told me that this cliff's 100 metres high, and they've asked me how far has the boat moved, so they're asking me for that. So again, I'd look at this and say, okay, this is a multi-step question. To work out this distance, I'm going to need to know that full distance that this boat is from the cliff, and then I'm going to need to take away this distance that once it's moved it is from the cliff. So I'd be looking at this and thinking, I've got two triangles here. You can see it looks messy, so that's why we need to draw these triangles, these additional triangles. I'm going to need to work out this distance in the big triangle. So here's my big triangle that I'm going to be working with first. I know the cliff's 100 metres. I know that I'm trying to work out this full distance here. Let's call that y just for fun. And I know that the angle of depression, if I'm looking at this big triangle here, I'm looking at the angle of depression being 78 here. So that's my big triangle that I'm trying to work out some things for. And then I know I've got this other little triangle, so this smaller one that I'm trying to do things for. So my smaller triangle looks like this. Not quite as big. I know it's still a 100 metre cliff. I know that this time my angle is 84 degrees. And I know that I'm trying to work out this shorter distance, let's call it Z. So again, let's see if you can see the multi-step question that's going on here. I know that ultimately my final calculation of x is going to be that y, take away that z. So I know that's what my final thing is going to be. But I need to work out, and this has actually kind of got two feeder bits in it. I'm going to need to work out what is y and what is z. So it's kind of got two bits here. And to work out y and z, I'm going to need to use trigonometric, the SOHCAHTOA relationships. So let's have a look and see if we can work those out. These are right angles, of course, because it's the cliff and the ocean. I say to myself, okay, here's my triangle. I've got two sides, but I need an angle in this triangle. Well, my angle of depression isn't in the triangle, it's up the top here. So remember we said earlier that there's two ways of getting one of these angles. You can either say this is 90, so that angle will be 90 take away 78, 12. Or you can say, here's my z here, in which case this one will be 78. Doesn't matter which one you say, it's up to you, but you need to work out one of them. So now I'm going to use SOHCAHTOA. And which rule I use depends on which of those angles I worked out. I'm just going to assume that you're dealing with this angle for whatever reason, and I'll do the other one for the second question. So here's my angle, here's my side, that one's clearly opposite, this one's clearly adjacent. So opposite and adjacent, I'm going to be using tan because I know that it is TOA, opposite and adjacent. You can use your formula sheet because you get it there. So here's my formula, tan of 78 equals opposite over adjacent. Plug it in, opposite is 100, adjacent is y. Of course, I'm trying to find y. It's on the bottom, so I need to do my switcheroo. Gives me y equals 100 over tan, 78. Let's have a look. 100 over, oops, not take away, 100 divided by tan, 78. You guys will use your fraction button because I know you like doing that. 21.255565617. Remember, keep all those decimal places in. That's what you should be doing. There's my y. Tick. Just done that calculation of my y. Now let's do z. I'm going to use the other angle this time. This is 90 degrees. If that's 84, and I know this isn't to scale, doesn't matter. 90 minus 84 will tell me what that is. This is 6 degrees. Obviously not to scale. Okay, from this point I've got, this is my opposite. and this is my adjacent. So I'm still going to use tan, but obviously it's a different relationship here. So I'm going to use tan of 6 degrees equals opposite over adjacent. My opposite side here is my z. My adjacent is my 100. My z's on the top, so that's all good. I just need to get rid of divide by 100, so I bring that up and multiply. I get 100 times tan 6 is going to equal z. So I've got 100 times tan of 6 equals z. So z in this case is 10.5104233 gives me z. Final step of my question, of course, what I was trying to do was to work out this distance here. Well, I've worked out that this all the way along is 21 metres. I've worked out that this bit here is 10 metres. So this is going to have to be the difference between them. So it's going to be, I'll just do it here, y minus z. So my y was 21.2. I'm just going to write 56, but you'll type it all into the calculator. And I'm taking away the 10.51. Again, you'll type it all into the calculator to get what it gives you. Let's work it out. 21.25565,617. And I'm taking away 10.51042353 gives me 10.7. Now, at this point I can round. 10.75 metres is how far that boat's moved. So you can see in this question, like in the last one, drawing these diagrams is so important because things get messy and confusing and you'll find yourself mucking something up. So hopefully you've got your head around some of those multi-step equations, well, not multi-step equations, sorry, multi-step questions and the processes involved. Remember, the main tips are put in everything that you know by using those angles. Then, of course, choose the right formulas to use. Make sure you're choosing the right ones. Draw your diagrams nice and big to make sure that you're not messing anything up. And then, of course, go about doing your calculations. Make sure you're working with the angles, of course. But all the best with all of those things, and all the best in your test, of course.